dear friends. I welcome you all to this course on metal casting. I am Dr. D. Benny Karunakar and I am from the Mechanical and Industrial Engineering Department of IIT Roorkee. My email address is given below. It is bennyfme@iitr.ernet.in. I will be covering various topics of metal casting in the subsequent lectures. Today, first I would like to give you the introduction on the metal casting. Metal casting is the oldest manufacturing process. Today, there are so many manufacturing processes are there, like machining or modern manufacturing process, welding, forming. Compared to all these manufacturing processes, metal casting is the oldest manufacturing process. It was in practice around 5000 BC in the ancient Mesopotamia and ancient Egypt. Today, its applications include all areas of human requirements. We have applications of the metal casting in the automobile industry. The automobile engines are manufactured by metal casting. The aircraft engines are manufactured by metal casting. The turbine blades, the turbine housings and machine tool structures and many more are manufactured by metal casting. So, first of all, what is the principle of the metal casting? I would like to draw your attention to the spears used in the wars during the ancient days. Here you can see the spears. So, these are all the spears. You can see there is a pointed head will be there, which is made up of metal, and there will be a wooden handle will be there. So, these are the spears. These were used in the wars during the ancient days. Here we can see a photograph or a picture of an ancient war taking place, and here you can see a soldier is carrying a spear, and here most of the soldiers are carrying the spears. These spears were widely used in the ancient wars. Now the question is, these spearheads were manufactured by metal casting. You can see these spearheads. So, these were manufactured by metal casting, means even during the ancient days this metal casting process was in practice. Now, let us see how the ancient people have manufactured these spearheads. Here you can see, first of all they wanted to manufacture 3 spearheads. What they have done is, they have made a wax model. Here you can see this is the one spearhead and this is another spearhead and this is the third spearhead. These actually these are the wax models. Initially they have made the wax models of the 3 spearheads and they have joined them, and in between at the center there is a tree, and they have joined again, and there here we can see a projection. So, this is a wax model. After making the wax model, they have compacted the sand around this wax model. You can see they have compacted. After compacting the sand, they have heated this system. Before that, they have made a hole at the bottom. Then what happens? After making the hole at the bottom, after heating the system, the whole wax will be melting and it might have drained outside, and around that there is the compacted sand is there, which is mixed with the clay, which has got some binding action. After this wax has drained out, there is a cavity inside. Now, what is the shape of that cavity? That shape of that cavity is similar to the wax model which they have made in the beginning. Now, they have melted the metal, maybe iron or the bronze, and they have poured through this hole. The molten metal has gone inside the cavity. It has occupied all over the cavity. It might have filled this first spear space, this another space, and after filling all this space, it has raised like this. Once the metal has raised to this level, they have stopped pouring the metal. After some time, the molten metal has solidified, then after it has solidified, they have broken this sand. Now you can see there is an assembly of 3 spearheads. Now they have cut here, here they have cut, and here they have cut, and here they have cut, and finally they got the 3 spearheads. This is how the ancient man has manufactured the spearheads using the metal casting process. Now let us see the principle of the metal casting process. Now what we can say about the principle? A sand mold with required cavity is created first using the maybe a wax model. Sometimes this wax model is also replaced or substituted by a wooden model. Now after creating this cavity, the metal is heated above its melting point. Liquid metal is poured into the sand mold. The metal solidifies inside the cavity of the mold, and after some time the metal solidifies, then the sand mold is broken. After breaking the sand mold, the solidified part is removed from the mold. So this is the simple principle of the metal casting. Now the ancient man, initially he has made a wax model. Around that wax model he has compacted the sand, and afterwards he has melted the this wax model. Later this wax that was used to make the cavity was substituted by wood, metal, etc. The means initially one has to make a model to create that cavity. This model is known as the pattern. Technically it is called as the pattern. So ancient man has used the wax for the pattern. Later it was substituted by the wood and metal. Similarly, the ancient man has used or compacted sand around the wax pattern. Today yes, sand we use, but this sand is substituted by metal, ceramic shell and so on. So this is the simple principle of metal casting. Now before going to the further topics, let us see the timeline or the history of the metal casting. The metal casting process, according to the biblical records, reaches back almost 5000 years BC. It was even 5000 years before Christ. Casting process was used during the Stone Age to make the rudimentary tools. Let us have a look at the this one, Stone Age. Here we can see the depiction of the Stone Age. Here we can see all the people who lived during the Stone Age. Those days they used to make some rudimentary tools like arrowheads or the spears or the axe. With those they used to kill the enemies, or with those they used to kill the animals for their food. Now let us see how this Stone Age man has used this metal casting technique. Here you can see this man is using the arrowhead. This arrowhead was manufactured by metal casting. Here you can see this man is holding a spear. You can see this spearhead was manufactured by metal casting by the Stone Age man. This man is also holding an axe. Here you can see this axe head was manufactured by metal casting. So during the Stone Age, the ancient man has used this metal casting process for manufacturing the arrowheads, axe heads, spearheads and so on. Now during 3200 BC, a copper frog was manufactured in the ancient Mesopotamia. This became very popular those days, and because of this copper frog, people even started calling those days as the copper frog age. Let us see this copper frog. So this is the copper frog which was manufactured during 3200 BC. This was manufactured by metal casting. During 1500 BC, wrought iron was developed. Wrought iron means worked iron. It contains very low carbon and also some slag. It was extensively used before steel was developed. Next, during 460 BC, bronze statue of Zeus was cast in Greece. Who is this Zeus? Zeus was the god of the sky and the ruler of the Olympian gods. Here we can see the bronze statue of Zeus, which was cast during 460 BC. He was considered as the god of sky. Now, this Zeus bronze statue is kept in a museum. We can see this bronze statue in a museum, and this was Zeus bronze statue was made by casting. Next, during 233 BC, cast iron plowshares were produced in China. We know the ploughing of the land. These plowshares were manufactured by casting. Here you can see a plough which is used to plough the land. This is the plowshare and this was manufactured by casting. During 1455 AD, yes, cast iron pipes were manufactured for transporting the water. Here you can see big cast iron pipes which are used to transport water. These pipes are manufactured by casting. Next one, foundry flask for loam molding was developed in the year 1709 AD by an Englishman by name Abraham Darby. During 1750 AD, Benjamin Huntsman reinvented the process of cast crucible steel in England, and during 1794 AD, cupola was developed by John Wilkinson from England. During 1809 AD, centrifugal casting was developed in England. In this centrifugal casting, there will be a cylindrical mold and this cylindrical mold will be rotating, and into this rotating cylindrical mold the molten metal will be poured, and as a result we get cylindrical castings with hollow space inside. So, this is the principle of the centrifugal casting. So, this was developed during the year 1809 AD. During 1897 AD, investment casting was rediscovered by Philbrook of Iowa. Investment casting means it is the casting process in which the pattern material is the wax. Some time back we have seen that ancient man has used wax as the pattern material, means to make the hollow cavity inside the compacted sand medium he has used the wax. Later this wax was substituted by wood and also by metal, but the process in which only wax is used as the pattern material is known as the investment casting. That was rediscovered during the year 1897 AD. Next one, he used this to cast the dental inlays. Let us say these dental inlays. You can see these are the teeth, and this tooth is damaged. So, here he has made a gold inlay on this tooth. So, for this purpose he used the investment casting. During 1947 AD, shell molding process was developed by J. Croning from Germany. So, here a chemical sand shell will be made. Into that shell the molten metal will be poured. This is known as the shell molding, and this was manufactured during the Second World War. During 1953 AD, hot box system of making and curing cores was developed. This eliminated the need for dielectric drying of ovens. During 1958 AD, Schroer was granted a patent for full mold process. He became the forerunner of the expandable pattern casting process. During 1968 AD, the cold box process was introduced for high production core making. During 1971 AD, Rio casting was developed at USA, and during 1971 AD, Japanese developed the V process molding. So, this became very popular. In this V process molding, the loose and fine and clear sand is used. This sand will be used to hold the what say mold cavity by means of the vacuum. Because of the vacuum, the loose sand will be held together tightly around the pattern. While the vacuum is still holding the loose sand tightly, the pattern will be withdrawn and the molten metal will be poured into the mold cavity. So, this creates a clean environment. So, this was developed by Japanese during the year 1971. And during 1996 AD, cast metal matrix composites were first used in the automobiles. Metal casting history in India. Now, let us see what was the history of metal casting in India. During 3000 BC, a dancing girl made up of bronze was manufactured at Mohenjo-daro. Now, it is in Pakistan. So, this dancing girl became very popular those days. Now, let us see this dancing girl. So, this is the dancing girl which was cast in Mohenjo-daro during 3000 BC. Now, you can see all the important features, all the minute features were excellently cast in this dancing girl. Now, it is still there in a museum in Mohenjo-daro, Pakistan. This was manufactured originally in India. So, India was also popular for the casting process. Now, during 375 to 414 AD, iron pillars, arrows, hooks, nails, bowls, etc. have been found in Delhi, Nashik and other places. Now, this is the iron pillar of Delhi. So, this was manufactured by casting and forging together. This iron pillar we can see near Qutub Minar in Delhi. So, this is the iron pillar of the Delhi. During 450 AD, large scale state owned mints and jewellery units were in operation. The process of metal extraction and alloying have been reported in India. During 500 AD, cast crucible steel was first produced in India, but the process was lost until 1750 AD when Benjamin Huntsman reinvented it in England. These are the important applications of the casting. The ancient man used this metal casting technique to manufacture the rudimentary tools like spearheads, arrowheads or the axe heads. Today, these are the applications. These are used in the automobile industries, aircraft engines, machine tool structures, electrical motors, compressors, locomotives and parts, pumps and accessories, turbines and blades, art castings, jewellery castings and miscellaneous components. Let us see examples from each of these applications. First, let us see in the automobile engines and accessories, what are the components manufactured by metal casting. You can see this is the cross section of a cylinder head, IC engine head. You can see here this is the cylinder and this is the piston. This piston will be reciprocating up and down, and here the fuel will be burned and hot gases are produced, and these hot gases will be pushing the piston downwards. In turn, the piston connecting rod will be rotating the flywheel. So, this is the simple principle of the IC engine or an automobile engine. This engine head is manufactured by metal casting. So, you can again we can see here, this is a cylinder, engine cylinder with 6 cylinders. This side we can see 3 cylinders and this side we can see 3 cylinders, and this is manufactured by metal casting. And this is another engine cylinder, 4 cylinders. Here you can see 4 cylinders are there, means maybe this engine is used for a heavy truck or even for a heavy car, and this engine is manufactured by metal casting. This is the again engine head, this is manufactured by metal casting. Now, this is the crankcase, This is also manufactured by metal casting. This is the cylinder head, manufactured by metal casting. This is the car rim, this is manufactured by metal casting. These are the transmission components, and these are also manufactured by metal casting. Now let us see the applications of the aircraft engines and the rocket parts. This is the aircraft engine which was used by the Wright brother during the year 1903. This engine was manufactured by metal casting. This is a 12-cylinder aircraft engine. 12 cylinders are there. Engine block, again this is manufactured by metal casting. This is an aircraft engine, you can see here, and here you can see this is the engine, this is the engine. This engine is manufactured by metal casting. Now you can see this is the modern aircraft engine. You can see all these turbine, blades are there, so many blades are there. All these blades are manufactured by metal casting. The outside covering, the cover or the housing is manufactured by metal casting. This is the again aircraft engine. All these parts are manufactured by metal casting. This is the rocket engine. You can see this rocket engine is also manufactured by metal casting. Now let us see the applications of metal casting in the machine tools and the structures. This was the lathe machine used by ancient man nearly 1000 years ago. You can see a heavy metallic structure, and you can see these are the legs of the lathe machine, and this is the bed of the lathe machine. So this is the tailstock of the lathe machine. All these parts are manufactured by metal casting. Now you can see this is a today's engine lathe machine, and all these components, the bed, the legs, the tailstock, and many components of the lathe machine are manufactured by metal casting. This is the lathe bed. So this lathe bed looks like this, and this is manufactured by metal casting. Now you can see this is the lathe carriage. Lathe carriage had got so many sub components like apron, saddle, cross ride, compound rest, and tool post. All these are manufactured by metal casting. Now this is the tailstock assembly. This tailstock of lathe is also manufactured by metal casting. Now you can see this is a drilling machine. This drilling machine, you can see this is the base, and this is the column, and this is the table. All these components, base, column, and the table, are manufactured by metal casting. Again we can see this is the milling machine. The milling machine base, the column, the structure is manufactured by metal casting. This is again a machine tool structure. You can see outside there is a thick casing is there, thick housing, and inside there will be so many components, moving parts, and levers will be there. The outside structure is manufactured by metal casting. Now this is the grinding machine, and you can see grinding wheel, and here one wheel is there, other side another wheel is there. This is the grinding machine housing, a thick shell. This is manufactured by metal casting. Now you can see these are the small machine parts, tiny components. These are also manufactured by metal casting. You can see small components with very excellent sharp details. These are manufactured by metal casting. Now let us see the applications of the metal casting in electrical systems. Yes, this is the electric motor housing. This is manufactured by metal casting. Now let us see the compressors. So this is the compressor frame. This is manufactured by metal casting. This is a heavy casting, you see, it weighs over 680 kgs, manufactured by metal casting. Now let us see the locomotive parts. Now this in a locomotive there will be flywheel like this. This flywheel is manufactured by metal casting. Now you can see this is a goods wagon, this is a goods wagon, and you can see here here is one wheel and here is one wheel, and there will be a frame which is supported on these two wheels. This is known as the side frame. This side frame is manufactured by metal casting. You can see this is the side frame. This side frame is manufactured by metal casting. Let us see the pumps and the accessories. This is the pump housing. This is manufactured by metal casting. Again, this is a big pump housing, and inside the turbine blade will be there and it will be rotating, and this pump housing is manufactured by metal casting. Not only this pump housing, the inside blades are also manufactured by metal casting. This is again a pump casting manufactured by metal casting. Now these are the turbines and blades. Let us see the applications in the turbines and the blades. This is the Francis runner, very important. This is manufactured by metal casting. This is the Pelton runner, which is very important. Again, this is manufactured by metal casting. Now you can see the steam turbine, which is used in the thermal power plants. The steam turbine, inside the rotor will be looking like this. So many blades are there, you can see, so many blades. All these blades are manufactured by metal casting of the steam turbine. Now this is the steam turbine housing. Just now we have seen the this steam turbine blades. All these blades will be mounted in this housing. You can see this is a huge casting, and its weight is nearly 10 tons. This housing is manufactured by metal casting. The turbine blades are manufactured by metal casting. The turbine housing is manufactured by metal casting. Now these are the impellers. These are also manufactured by metal casting. Now let us see the art castings. Now you can see this is the statue of Abraham Lincoln. Most of the times we used to see the bronze statues of the celebrities. How these statues are made? Initially they make a wax model of that person, and around that they make the compacted medium, sand medium or a ceramic medium. Later the wax will be melted and it will be drained out. Then they will pour the molten bronze into that cavity. That is how the art castings are manufactured. And here we can see the art casting of Abraham Lincoln, which is manufactured by metal casting. And this is again another art casting which is there in a museum in USA. This is also manufactured by metal casting. These are all the art castings manufactured by metal casting. So these are all the art castings. Next, metal casting is also used in the jewelry industry. Now you can see these are all the jewelry items. These are manufactured by metal casting. Now you can see again these are all the jewelry items. Of course these are all assembled. Later they will be separating the different parts. Initially they make a assembled casting. So this is manufactured by metal casting. These are all the again jewelry items. These are manufactured by metal casting. Miscellaneous components. Now you can see this is the nozzle. Maybe in a petrol bunk we can see this kind of nozzle. This is manufactured by metal casting. You can see this dumbbell. This dumbbell is used for the exercise purpose. Most of the times we use this, but we never think of how this is manufactured. This is manufactured by metal casting. These are the industrial castings manufactured by metal casting. These are the pulley castings. These are the submersible pump components. So these are all manufactured by metal casting. Now let us see the advantages of the metal casting process. Intricate shapes can be made. What is this intricate shapes? Maybe it has got so many complex features. Using the what say other machining process or the forming process, it may be very difficult to manufacture such complicated shapes, but using the metal casting process, these intricate shapes can be successfully cast. That is the advantage of the metal casting. Next one, the second advantage is the flexibility of size and weight. What is this flexibility of size and weight? Very small components can be manufactured. Just now we have seen that the metal casting has application in the jewellery industry. What is the weight of a jewellery component? Few grams. So, a small casting as small as few grams can be made by metal casting. Now, we have also seen the turbine blades, the turbine housings whose weight is more than tons, that is also manufactured by metal casting. Means there is a great flexibility of size and weight in the metal casting process. Next one, simple and inexpensive tools. There are no high tech equipments are required for the metal casting. Only thing is you have to create a hollow cavity in a compacted sand medium. For that initially one has to use a model, which this model is known as the pattern. After creating a hollow cavity inside the compacted sand medium, we melt the metal and pour into the cavity. So, it is very simple and no costly tools are required. That is the advantage of the metal casting. Next one, next advantage is high production rate. The production rate is very high. Next one, next advantage is any material can be cast. Both ferrous and non-ferrous materials can be successfully cast. Finally, the wastage of raw material is very less in the metal casting. So, these are all the advantages, and these are the important advantages, and let us see the limitations or the demerits of the metal casting. This is a labor intensive process. What is the labor involved? Initially, what is the principle of the metal casting? If we want to manufacture a particular component of a particular shape, a similar hollow cavity of the same shape has to be created inside the sand medium. For that, one has to initially make the pattern, that involves the labor, and after that one has to carefully prepare the sand, and that sand has to be compacted around the pattern very carefully, and afterwards the pattern has to be withdrawn from the compacted sand medium. That requires labor. On the other side, one has to melt the metal in a furnace. That has to be done very carefully, that should be handled very carefully, that should be brought to this moulding medium very carefully, then it should be poured into the cavity. This requires the labor. That is how the metal casting is a labor intensive process. Next one, the demerit of the metal casting is the dimensional accuracy is not so good, because we use the sand medium, right. So, there will be small irregularities on the sand surface. That is why even the casting will develop this kind of small irregularities on its surface. That is why we used to overcome this limitation, we keep the size of the pattern little larger, so that later we can machine the casting. That is how the dimensional accuracy of cast parts is not so good. Next one, the next demerit is the poor surface finish. Just now we have seen that the molten metal is poured into the compacted sand medium. Inside the compacted sand medium there will be a hollow cavity, and into that hollow cavity we pour the molten metal. The hollow cavity will have the small irregularities. Accordingly, even the casting will develop these irregularities. That is how the surface finish is very poor in the case of the castings. Next one, the casting process requires close process control. Means the moulding medium has to be prepared very carefully. The moulding sand contains the base sand, and the clay and the moisture. This clay and moisture should be controlled very carefully. If the clay is less, the binding of the medium will be very less and it may break, and if the clay is very high, then what happens, the ability of the hot gases to pass through the sand medium will be very less. So, these hot gases will be accumulated inside the mold cavity and they may lead to defects. Similarly, the moisture or the water in the sand should be controlled very carefully. If the sand is if the water is very less, what happens, the binding action will be very less, the molding medium may break. On the other hand, if the moisture content is very high, what will happen, when we pour the molten metal, this molten metal comes in contact with this moisture, immediately this moisture will turn into vapor. If the moisture content is reasonable, it will escape. If the moisture content is very high, the whole steam may not escape outside and part of the steam will be staying inside the mold cavity and this will develop into defects. Next one, there are defects can develop in the castings like blowholes, hot tearing, misruns, inclusions, metallic projections, shrinkage porosity. These are some of the defects of the castings. In fact, all these defects we will be studying later in detail. So, these are the important defects. What are these defects? Let us see. So, this is, you can see few defects here. So, this is a blowhole, means what happened, the moisture content was very high and the clay content was very high, excessive of hot gases and steam was produced and the excessive steam was not able to escape through the sand medium because the clay content was very high and the steam is occupying on the surface of the cavity. That is how we can see large holes on the surface of the casting. So, these kind of holes are known as the blowholes. This is a defect and this kind of defects can occur in the casting. Now, you can see another defect is the hot tear. Hot tear means a crack on the casting during the solidification process. There are several reasons for the hot tearing, but we are knowing that there is a hot tear. We will be learning the reasons for this and how to overcome these defects in our subsequent lectures. And here we can see another defect called misrun. This misrun means here it is a kind of what is a closed vessel and here you can see the metal has not occupied the thin what is a portion, because the casting has got a thin surface, thin what is a cross section, the molten metal could not flow at particular location. This is known as the misrun. This is of no use. Now, why this misrun is happening, and we will be seeing in our next lectures. Next we can see these are the inclusions. Inclusions means foreign particles like slag or sand particles will come along with the molten metal and they occupy on the casting. Here you can see an inclusion. So, again this is a defect. Next one, this is a metallic projection and this is the actual casting, but here you can see some projection is there which is not required. This is again a defect. Next we can see another defect called shrinkage porosity. Now, you can see this is the casting, but inside there is a hollow cavity, a depression. So, this is a shrinkage porosity. Again we can see this is the casting and inside there is a hollow cavity which is not required and which is detrimental. This is the shrinkage porosity. Likewise, there are more defects. These defects should be minimized, otherwise if sufficient care is not taken, these defects will be persisting and it is a loss to the industry. And all these defects we will be studying in detail in the next lectures. Now, finally, the classification of the casting process. The casting processes can be broadly classified into 4 types. One is the conventional molding process, second one the chemical sand molding process, the third one permanent mold process, and the fourth one the special casting process. Under the first one, under the conventional molding process, we have green sand molding, we have the dry sand molding and we have the flaskless molding. Green sand molding means where there is moisture. In the molding sand or in the mold, if there is moisture, then we call it as the green sand mold. In some cases, for making the large castings, what they do is, after making the mold, they take this mold and dry it so that the moisture will be dried out. This is known as the dry sand molding. And in all these cases, we use the molding flasks. And what is this molding flask we will be seeing in the next lecture. And there is another process under this conventional molding process, that is the flaskless molding. So, under the conventional molding process, we have these three: green sand molding, dry sand molding and the flaskless molding. And the second broad classification is the chemical sand molding process. Under this chemical sand molding process, we have the shell molding, we have the sodium silicate molding, we have the no-bake molding. And in the third category, that is the permanent molding process, we have the gravity die casting and also the pressure die casting. Some time back I have told you the sand mold medium was later substituted by the metal also. Here, instead of using the sand medium, we use the metallic medium. Into a metallic mold, we pour the molten metal. And in one case, into the metallic mold, we pour the molten metal because through the gravity. And in another case, we apply external pressure into the metallic molds, and that is known as the pressure die casting. Again, this pressure die casting is subclassified as the cold chamber pressure die casting and hot chamber pressure die casting. In the cold chamber pressure die casting, the furnace will be away from the cold chamber pressure die casting machine, whereas in the hot chamber pressure die casting machine, the furnace is an integral part of the die casting machine. And in the fourth category, the special casting process, we have investment casting, continuous casting, vacuum sealed molding. This also known as V process. And next we have the squeeze casting process, centrifugal casting, stir casting, plaster molding, evaporative pattern casting, ceramic shell molding, slush casting. So, all these we are going to learn in the subsequent lectures. Friends, today we have seen the introduction to the metal casting, when it has originated, how it has originated, how the ancient man has used this technique to manufacture the rudimentary tools like the spearhead, axe head or the arrowhead, and how this process has developed and what is its role in today's world we have seen. And we have seen the important applications of the casting process in the modern world. And if there is no casting process, today we have to shut down the power generation industry, we have to close down the automobile industries, we have to close down all the machine tools, no space applications, no aircrafts, nothing is there. So, the metal casting has become part and parcel of the human race. We are going to learn more topics in the subsequent lectures. Thank you very much.